Hello, I'm the Bio Guy, and this is the General Biology series. In the last episode, we learned how to determine if bonds and molecules were polar or nonpolar. We also learned to assign partial charges to atoms that are bonded to other atoms via polar covalent bonds. In this episode, we'll see that partial charges interact with the incredibly important hydrogen bond. But first, let's review polar covalent bonds and partial charges. This molecule is water, of course. We see that the oxygen is covalently bonded to two hydrogens. This means that the oxygen is sharing a pair of electrons with each of two hydrogens. To understand the properties of water as a whole, we want to know if the electrons in each of these bonds are shared equally or not. So I've got some questions for you. First, what information do we need to know about oxygen and hydrogen to determine if the electrons in these covalent bonds are shared equally or not? The answer is that we need to know the relative electronegativities of the two. If you got this question correct, congratulations, you've got the foundation you need to start building more complex information. So the electronegativity of oxygen is considerably greater than that of hydrogen. So which atom will be more capable of withdrawing electrons to itself? Oxygen is the answer. Next question. Would we say that those covalent bonds are polar or nonpolar? And the answer is polar. Now, let's think about the nature of oxygen and hydrogen in the water molecule. How would we describe the condition of oxygen? Partially negative is the answer. And how would we describe the condition of each of the hydrogens? Partially positive. Again, if you've gotten these questions right, you're really doing very well. We also see two pair of dots on the oxygen. These represent electron pairs in orbitals of oxygen. These electrons will repel the electrons in the covalent bonds, creating a V shape to the water molecule. As a result, one side of the molecule is partially positive, and the other side of the molecule is partially negative. Thus, water is a polar molecule. Indeed, it is the poster boy of polar molecules. We can refer to polar molecules as hydrophilic, which means water-loving. Now, the next thing we want to know is what would happen if two water molecules came in close proximity to each other. Well, I'm confident you know that opposites attract, and the same is true for partially charged atoms. The partially negative oxygen of one water molecule will be attracted to as many as two partially positive hydrogens of other water molecules. And what we've drawn here is the hydrogen bond. This bond we see throughout biology, so let's look at other hydrogen bonds and see if we can develop a definition for the hydrogen bond. Here we have ammonia and water, and we see that the two can be drawn to each other in a couple ways. The partially negative nitrogen of ammonia can interact with the partially positive hydrogen of water. Also, the partially positive hydrogen of ammonia can interact with the partially negative oxygen of water. So how can we define hydrogen bond? Well, all we have to do is describe what we see in this picture. First, note that I've used a dotted line to represent the hydrogen bond. That's because this bond is non-covalent. It does not involve sharing of electrons. It is simply an attraction between atoms with opposite partial charges. So the first part of our definition states that the hydrogen bond is an attraction. Now, let's simply list what the attraction is between. Well, in each of these hydrogen bonds, we see a partially negative atom, and we always see a partially positive hydrogen, hence the name hydrogen bond. So, what we've got is that a hydrogen bond is an attraction between a partially negative atom and a partially positive hydrogen. I hope this was helpful, and in our next lesson, we'll see hydrogen bonds in action as we explore some of the properties of water. Thank you very much for watching.